Day 3, Problem 1. A 25-foot ramp has a horizontal length of 23 feet. Part A, sketch a diagram. So I'm going to draw a right triangle to be this ramp. We're told that it is a 25-foot ramp, so it is the surface of the ramp or the diagonal side of the triangle that gets labeled 25 feet, and that the horizontal length is 23 feet. In Part B, use the Pythagorean theorem to find the ramp's height. So that is a squared plus b squared equals c squared. The letter A is the shortest leg of the right triangle, which is this side here. And so I'm going to label it with A. And in the equation that we're writing, that's the one that will stay as a variable. These other two letters are going to get filled in with numbers. The variable B gets filled in with 23, and the variable C gets filled in with 25. To solve this equation for the letter A is going to necessitate subtracting the 23 squared. So subtract 23 squared, subtract 23 squared. The a squared can be brought straight down. 23 squared subtract 23 squared is 0. And that is equal to 25 squared subtract 23 squared. So I'm going to grab a piece of scrap paper and we're going to figure out 25 squared subtract 23 squared. 25 times 25. 5 times 5 is 25, carry the 2. 2 times 5 is 10, plus 2 is 12. Start the next row with 0. 2 times 5 is 10, carry 1. 2 times 2 is 4, plus 1 is 5. Adding together, this is 5, 2, 6, 625. Now 23 squared. 23 times 23. 3 times 3 is 9. 2 times 3 is 6. Start the next row with 0. 2 times 3 is 6. 2 times 2 is 4. And add together. This is 9, 12, carry the 1, and 5. 529. And so we're trying to figure out 625 subtract 529. Borrowing from the 2 creates 1, and the 1 that we borrowed can be brought over in front of the 5 to create 15. 15 subtract 9 is 6. Now 1 subtract 2 I can't do, so I'm going to borrow from 6, leaving 5, and the 1 that I borrowed comes over in front of this 1 to create an 11. 11 subtract 2 is 9, and 5 take away 5 is nothing, so 96. So when doing the subtraction on the scrap paper, we find out it is 96. So a squared is equal to 96. Using a square root, we can find the solution for a. The square root of a squared is a. And now the square root of 96. Well, the square root of 100 is 10, and the square root of 81 is 9. The square root of 96 is in between the square root of 81 and the square root of 100, and so its value will be in between 9 and 10. It is going to be 9 point, and then we'll take a guess at the tenths position. Now 96 is not halfway between 81 and 100, it's closer to 100, and so we need to guess a digit that's not 0.5. 0.5 would be if it was halfway. Perhaps 0.8. 9.8 is going to be my guess for the square root of 96. The variable A is this side of the right triangle, which is the ramp's height, and so we've discovered that the ramp's height is 9.8 feet. Now problem 2. Part A, graph figure ABCD. Point A is 0, 0. So right here at the origin is point A. Point B, 2, 4. Over 2, up 4. Here is point B. Point C, 3, 4. Over 3, up 4. Here is point C. And point D, 4, 2. Over 4, up 2. Here is point D. Connecting these together, we get a four-sided figure. That is part A of the question. Now part B, graph its dilation if the scale factor is 2.5. We're going to create a larger four-sided shape that is the same shape as this, but we're going to use a scale factor of 2.5 to enlarge it. To find A prime, we start with the ordered pair for A and multiply by the scale factor of 2.5. So 0, 0 multiplied by 2.5, but that still makes 0, 0. And so point A prime is actually in the exact same location as point A. This dot is both point A and it's point A prime. Now point B prime. Start with the coordinates of B, 2, 4, and multiply those numbers by 2.5. So 2 times 2.5 is, time for some scrap paper, 2.5 times 2. 5 times 2 is 10, carry 1. 2 times 2 is 4, plus 1 is 5. 1 digit to the right of the dot, 5.0, or just 5. Now for the y-coordinate, how about 4 times 2.5? Scrap paper again. 2.5 times 4. 5 times 4 is 20, carry 2. 2 times 4 is 8, plus 2 is 10. 1 digit to the right of the dot, 10.0, or just 10. Now point C prime. Start with 3, 4, and multiply each by 2.5 to find the ordered pair for C prime. So 3, 4 times 2.5. 2.5 times 3. 5 times 3 is 15, carry 1. 2 times 3 is 6, plus 1 is 7. 1 digit to the right, that's 7.5. And 4 times 2.5, we had figured out earlier, was 10. Okay, now point D prime. 4 times 2.5, again that was 10. And 2 times 2.5, we had done that one earlier, and that was 5. And so these four ordered pairs will get us our dots that we need to create the dilation image. We've already figured out 0, 0, so now let's find 5, 10. Over 5, up 10, here is B prime. 7.5, 10, over to 7.5 and up to 10. Here is C prime. And 10, 5, over to 10, up to 5. Here is D prime. We can connect those dots together and that will create our four-sided shape. So connecting point B prime to A prime and connecting B prime to C prime, connecting C prime to D prime, and finally A prime to D prime. The red four-sided shape is a larger version of the original shape that was drawn with the black ink. The drawing itself is part A, and then these ordered pairs are the coordinates, that's part C.